Good afternoon, everyone. Welcome to this Advanced Steel webinar on all the checking tools you need to do for your model. So about me, my name's Rob Merriman. I'm one of the application engineers here at Graitec. So I've been working in the construction industry since I left university. Now work for Graitec UK as an application engineer, providing support, implementation, customization, mainly for Advanced Steel, but now we're looking at all packages within the AC collection. So normally you would get a little slide now about previous webinars and upcoming webinars, but this has now all been put into our Advanced Steel content portal. So in this webinar, there is a handout, so you can download a PDF document from the webinar. If you click on the links, it will take you to our portal. So all of our previous webinars are there. All of our blogs are there. If you haven't already subscribed, I would ask you to subscribe to our blogs. Every time we do a new blog, we try and do 1 or 2 a month between myself, Alec, and John and Tommy. They'll come straight through to your inbox. And then any future webinars, any future webinars, we do have an events page, so that is all of our webinars, not just the Advanced Steel ones. And if you connect with me on LinkedIn, every time there's a new batch of webinars, I will post the links and the dates on LinkedIn. So an overview of what we're going to look at today. We're going to look at the clash check, the steel construction technical check, the model check, loose part check, what's attached in the workshop, how it's attached, and then we'll also look at finding rogue welds where we've manually done something and it's not welding as we would expect it to. So we're going to jump straight into a model and get cracking with this. With this, all these checking tools, whether it's an entire job like this or whether it's just 3 beams as some support steels with a couple of plates on, I used to always do the same checking tools on every project, because you can guarantee that on the small ones where you assume it's all okay, that's where you will get errors. So all I'm trying to do here is pick up any errors within the model before we actually get to the fabrication drawings, because if you get your fab drawings and you've got problems on there, you've then got to delete the drawing, correct the model, run the numbering again, rerun any new drawings, update any old drawings, and that is quite a time-consuming process. So a little bit of check-in on every job will save you a lot of time in the long run. And we also want to pick up any issues before we get to site. With steelwork, if issues get to site and they haven't been picked up by us, the workshop manager, the project manager, they can be very costly. So we're going to start with clash check. It's the most commonly used checking tool. It will check certain parts. It will check that and will report to you if items within your model are hitting each other. So if you've got no clashes, you'll get, so what I'll do, I'll draw a little window around these items here. The clash checking tool is this little button here. So we've got a checking panel, which is where we're going to be working today. You've got the clash check tool. So I have only a certain number of items selected. So when I do the clash check, it's going to clash check those items. And the reporting tool says collision check found no errors for what I had selected. If you don't select anything, it will clash check the whole model. So you can see it's running in the bottom of the screen down here. And now I get the reporting tool for all the clashes that I've got in the model. So what you have is you have the ID number. Object number 1 is clashing with object number 2. The coordinates relative to the 0 point in your model, and then the volume of the clash. In your object 1 and object 2, if you get these bits that say not defined, that's because you haven't numbered those particular elements within the model. So some of this model is numbered, some of it isn't, so that's where the not defined is. The clash check will always put, although the volume is showing a 0 in here, the last number in the ID, so the last clash, is always the clash that has the biggest volume, so it's the biggest issue that we've got to resolve. So my advice would always be fix the big clashes first, because you'll find that a lot of the smaller clashes will disappear when you fix the big clashes. To locate a clash, probably always best to be in 2D wireframe, and all you have to do is double click on the clash and it will then highlight in red with a marking your clash. So this is a temporary block. So on our tool palette, we can go to the selection tab. There is a button to say select marked objects, and you can see that angle in there is clashing with the web of my beam. So it says in here, the RSA is clashing with the 305. With this temporary marking, this block that it creates, we can measure on it as well, so you get snap points. So I can see that's clashing. I've got that angle a millimeter into the web of the beam. So always start with the largest clash to begin with. If you want to get rid of the marking, there's a little button here. Sorry, this one here, clear marked objects. That will get rid of your marking. So it will clash check items that are hitting each other. It will also clash check tool clearances around all the bolt heads and nuts, and it will also clash check that you've got enough room to get a nut in there. So I've got a couple of deliberate clashes in here. You can see the clash, the volume is not around the nut, but the system is saying you can't get a socket around the head of that bolt or the nut of the bolt on that connection. So it will give you a warning. Now, you can say, well, that's fine. We'll use a spanner. We're not going to use a socket. That is not a problem. So we want to remove these two clashes from the list because we can't fix them. So what you can do is you can select that, and you've got this button here, second from the right, ignore object. That will remove it from the list. So you can see now it's not correcting the clash. All it's doing is it's removing it from the display. Now I'll just get rid of all of them. You've got to do them one at a time, so the system won't let you select all of the clashes accidentally and remove them. Now if I close that dialog and I re-clash check this, I will not get that little reporting bit that clash check found no errors, because the system is still finding errors. So this is saying I've done 4 clash checks in this model today. If it goes to this blank page, it's telling you that there are clashes that you have ignored. Now, say I was doing this model and I ignored them, but I passed it on to one of my colleagues for them to double check the model. You can reset those ignored objects by pushing this button in here. And that will bring all of the clashes that you've ignored. Just be careful. I've done this on a project where I had lots of clashes I needed to ignore. If you push that reset button and save the model, you can't undo it to get rid of them. You've then got to go through each of them individually and get it out and remove them again yourself. So just from experience, just be careful when you push that ignore button and reset that ignore button. What I would say is never leave your clash checks to the end of the project. If I was starting a new project, and I'm just going to put a little port frame in, and I put a connection on. I would not finish the modeling without clash checking this. I would just do a little window around that, clash check it. I've got no problems. Because if I had 15 bays and I had 4 clashes on that connection and I copied it to each column, that's 30 clashes. Just on the 2 columns, then you copy it 15 times, that's a lot of clashes. And if you'd have just corrected it in the first place, you wouldn't have got those clashes. So don't leave your clash check until the end. Do it as you go along. It takes literally a second just to draw a little window around these two items once you put the connection on, and it says collision check found no errors. You can, I will show you this, but I will put a big warning that you have to be very careful with what you do on this next bit. You can completely ignore certain objects from the collision check. So if I clash check around this column base here, I think I've already done it, so let me just untick that. If I clash check around here, it will say that the foundation is clashing with 4 of my anchors. We go in here, we've got that marking in there, so you can see that the anchors are clashing with the foundations. Now, you're not going to correct that. The only way you could do that is to ignore it. But with elements, if you double click on them, you can go to the behavior tab and say, do not take this foundation into consideration for clash checks. So if I do a window around that, it will now say collision check found no errors, because I've told the system, no, do not take this foundation into consideration when you're doing your clash checks. The reason I said you've got to be very careful with this is if I had a beam through the middle of that foundation, it will still say collision check found no errors. So if you turn the behavior off for clash checks because you want to remove clashes quickly, you just have to be aware that it is not clash checking that foundation against anything else in the model. So that's why I would recommend that you just take the time using the ignore option, because you can ignore the anchors clashing with the bolt, but then you can see that this clash here is the problem that we want to resolve. So that is clash check. The next check I'm going to use is the check underneath it, is the steel construction technical check. Now, I only use this for 2 warnings. Now, it will show me a lot of errors. It's saying some bolts in the bolt pattern are too close to the object's edge. There is a value in advanced steel. It's not, as you as steel detailers or engineers would know, you guys will work on usually 1.5 times the bolt diameter from the edge of the plate. The system, it's more of a variable, so it takes a lot more things into account. So it's not 1.5 times the bolt diameter. So I've set all of these plates up based on my engineer's connection. So it's the engineer's responsibility to look at edge distances, because his connection software will take into account the edge distances. What I'm going to do is I'm going to sort this by description. Scroll to the very bottom, so I'm ignoring all of the ones that saying they're too close to the object's edge. But what I'm interested in are these 2 bits here. Some holes in the hole pattern are outside of the connected object. So in this beam here, I've got holes in the top flange for timber, but it's telling me that I've got holes outside of that object. So what we'll do, we'll isolate this beam. And if I go to turn the features on, so if I go display type and then say show me the features, you can see that I've got a set of holes at the top here that are outside of the object. Now if we ran the NC data for this, we would need to correct this, because if we gave a supplier NC data this, there's a potential that the machine would then try and drill through this floating bit at the end. When you run the NC data will also give you a warning about the holes being outside of the object, but I don't want to get to the point where I've numbered before I run this. So what I'm actually going to do is I'm just going to change the hole pattern to say it's 14 holes, not 15, or I could have moved them, because if I select this now and do the steel construction technical check, it has said that it found no errors with this beam. So that's one check that I would use in there. Holes are outside of the object. The other thing that I'm looking for in the steel construction technical check is welds do not connect to anything or only connect to one element. So a weld by definition cannot connect to one element, because a weld is to weld 2 elements two plates or two beams or a plate and a beam together. So if you've got welds in the model that are only connecting to one element, you've forgotten to select something, or you've got a rogue weld, or you've copied something. So again, we could go around and then delete these welds, check what they're attached to, which is what we're going to get to in a minute. So that's what I would use the steel construction technical check for, just those two elements. Again, I would do that on every project. Then we're going to move on to the model check. So the model check will check for items in the model that don't make sense to advanced steel, so go against the advanced steel programming. So if I click the model check, most of the time you'll get model check found no errors, but I've got two of the most common ones in here. So again, it's the same as the class check and the steel construction technical check. You get the ID. If you double click on it, it will take you to the beam and it will tell you what's going on in here. So the two I've got says beam body can't be calculated, shortening cuts the entire object. What I have in here is I have this section of beam that I've drawn, but what I've done is I've applied two features to it. So the beam is, if we go to the properties, the beam is 300 long, but if I turn the features on, I've got two features in here, and the two features cut away the entire length of the object. So to the system, there is no physical length of beam, so it can't have a number, it can't go on a fab drawing, can't go on lists, so that is a problem to advanced steel. So the model check has told me that. The other one, if you ever lose that dialog, as I've just done here, there's a button here that says data panel, that will bring it back for you, or you could just hit the model check button again, is I've got overlapping shortening. And what I've done in here is I've accidentally, again if I turn the display type on, I've got this feature here which is the shortening, and if I delete it I've still got another feature. So I've got two cuts on that column. So again, when we went to run the NC data, the NC data would say cut the column at this length once, and then it would say cut it again, because to the system it's two different cuts. Now with model check, you've got these two little options in here at the bottom, which is fix all errors and fix selected errors. So with a model check, if the system can do it, it will attempt to fix it for you. So I'll push that button. The one where I had two bits of shortening, it has removed one of them, and you can still see I've got that little bit of beam in there. So it's removed one, so that length now exists in the model. I am actually just going to delete that beam. The other one it couldn't fix, because what it's saying is the beam shortening is part of the connection. You need to go and sort the connection out. So one of my features is for the connection. So if I delete the first one, you'll see the connection box stays. So I've deleted the correct one, because if I select the second one and delete it, it removes the whole connection. So if I now run my model check, it'll go back to my notification tab to say today you have done 16, or you've done 16 operations that I can report on. The 16th one says model check has now found 0 errors. So again, that is what I would do on every project. Always run the model check, because it's all about finding these errors before you get to the fabrication stage. Now we're going to move on to the checking tools to make sure that things in my model are welded up as I would expect them to be. And I want Advanced Steel to show me any loose parts. So for the loose parts, we're going to go to the Output tab. And there's a little button in here which is a sort of red lifting lug that says Mark Loose Parts. So that says it searches the entire model and highlights the unconnected parts. Now, unconnected parts are parts that are not connected to any other part in the workshop. So if you've forgotten to weld something, it will show it in there. If you've got a beam that's got two fin plates, it would show that as loose. So you run that, it says I've got 54 loose single parts. What it does is it marks them in red. So what I'm going to do is I want to isolate all of those. So I choose the select. So those objects are marked in red, but they're not selected. So on my Selection tab, I use the select marked objects. Then I'm going to go to my quick views and choose show only selected objects. Then I'm going to go back and clear the marking. So these are all my loose parts. And now personally what I would do is I would go, right, well the concrete foundations, they are all supposed to be loose. So I can select all of those and I can turn them off. These folded treads, it's saying these are loose because these are being delivered to site as their own component, and on site they're being bolted down to the staircase. So again, I can select all of these. This is the process I went through as a detailer and went, right, those are all fine. There's nothing underneath there. So I'm going to select those. Then we get to the bits that should be welded. This angle should be welded to the beam. So that is a problem for me. These bits aren't supposed to be loose, but I'm going to get to those in a minute. And then I've got these cap plates in here. Now those are not supposed to be loose. Those are supposed to be welded to the column. So I've got a problem with my assemblies. So again, I want to pick this up before I get to the fabrication stage, because if I ran fabrication drawings, these would get their own assembly drawing. They would then get painted or powder coated or galvanized. If the fabricator hadn't picked up that they were supposed to be attached to anything else, he might assume that you want this little angle to be bolted on site and not anything else. So we don't want them to get to site and then we realize that they should be welded, because then we've got to grind all the galvanizing or the paint or the powder coating, weld it on site, touch it all up, and then, or even send it back to the workshop to have everything stripped off. Then there's the cost of delaying the installation of the staircase and the columns and the balcony and things like that. So you always want to do all of these checks today. I did on every project. So what I'm going to do, I would then come in here, have a look at that and go, right, that should be welded. So to weld something manually, I choose the weld point here, select the two items I want to weld together, and then I'm just going to say, well, we're going to put the weld in there. For these cap plates in here, those have a connection, so I did a cutter object. So I double click that joint box. If I go to the cut tab, there is the option to add a weld in. I just forgot to tick it. And again, I have the joint box in there, so I can go to the cut tab and I can click the create weld. Because now if I close that down, clear my marking and do the loose parts again, so that's the output tab, mark loose parts, I've now only got 51 loose parts. And if I isolate those, you'll see that it's no longer the angle underneath here. It's no longer the column cap plates. It's just to the bits that I know are supposed to be loose. So although it's calling it loose, it's items that are not attached to anything else in the workshop. There is another tool that we can use for that that would highlight those problems, and that is on our selection tab, this little button in here, clear marking and display objects connected in the workshop. So anything that you are modeling manually, that you're putting manual connections on, not through the connection vault, maybe you're using the weld option in here, maybe you're using some of the features where you have to remember to tick the create weld option. I would always, once you've finished your modeling of that particular area, use the clear marking and display objects connected in shop. This little balcony frame I want delivered as one welded frame. So when you do that, it will clear any marking, click on any element, and it will mark in red for you anything else that is attached to whatever you clicked on. So these little tie beams in here should be connected. And the reason they're not is there is a connection in here that I've used the parametric notch connection. So that is this connection here. But again, you have to remember to, well, I have remembered to tick the create weld, but if you have a look at the weld location defaults to site. So the system is saying that this beam is going to be delivered loose, but you're going to weld it on site, whereas I want it welded in the workshop. So if I change it to shop, and now I repeat that clear marking and display objects connected in shop, that one beam is now attached. So I've just got to go in and change the other connections. Now what we can do, rather than double clicking on each one, I know it's these boxes here, these boxes here, and this box on the outside here. I want to take the values of this box that I've just connected and apply them to all those other ones. So what we can do in extended modeling, you have a joint utilities panel, and there is this little button in here, transfer properties. So this is similar to your match properties in plain AutoCAD. So I can transfer the properties of one joint to all the other joints. So I will say, the only thing with this connection, this macro, this tool, is that it works the other way to match properties. So you choose the connections that you want to modify. So that's these ones here. Then you right click to finish your selection, and then you say what are you matching those connections to. So it's this one here. That will update those. So hopefully now when I do that clear marking, all of those have now changed to red because they're attached in the workshop. And if I double click on one of these connections, we'll go into the welds. You can see they've all updated to shop. So there's an extra little tip for you today. That is transfer properties of joints. We have written a blog on that. Alex done a blog about that tool a couple of years ago now, so it's a few pages back on the blog site. But in the handout, you've got the PDF document with the link to our Advanced Steel Content Center, and there you can access all of the blogs. So that's mark loose parts and display objects connected in shop. You can do a clear marking and display objects shop and site. And when you do that, hopefully your whole model will go red, because that takes into account the site bolts and the site welds. So again, if you select all of those, turned everything off that was attached in the workshop, you would be left with only certain elements. So we can actually see in here that I do have a few elements. I'll just tidy up and turn the joint boxes off. And I'll just turn the cameras off. And I'll just turn these model boxes off just for a second, just to tidy it up a little bit. Now, what I did there, so I did display objects connected in site and shop. So that takes into consideration the shop welds, the shop bolts, but the site welds and the site bolts. And actually, I've got two columns here that weren't attached. And it looks like I've modeled these without any bolts in. So if I turned everything back on, I've not put any bolts in there. So on site, although I've got holes everywhere, I must have modeled those as holes. I've not, so we would be 4 bolts short on site. I also have this little balustrade panel in here. Now maybe that I have decided that that is going to be welded up on site, but I should have put the welds in as site welds. So we've got the check objects connected in the workshop, but we've also got check everything connected on shop and site. So if you're missing any bolts or you haven't put a connection on, it will show you those ones. That show me what's attached in the workshop is quite useful. These columns in here are a column with a welded stub either side, with then a splice plate connection and a fin plate for this beam coming in. So the splice connection I've done with a connection vault. The fin plate I've done out of the connection vault, but the cut to the column I've had to sort out myself. So again, anything you're having to do manually and sort out yourself, it's worth just clicking on the column, making sure that everything in that assembly goes red. Because what I've done in here, again, is because I'm doing it manually, we bring human error into Advanced Steel. So any human error, I forgot to weld this stub here onto this column. So what you would get is you would get a workshop assembly drawing for everything that's red there. You would then get a separate drawing for that little stub and that plate on the end. So you might not pick up, and your workshop manager might not pick up, that that is supposed to be welded in there. So again, we want to do this before we run the drawings. So I can say, right, weld those two bits together based on the node in there. If I clear the marking and rerun that check, that's now all attached. So anything that you're doing manually, the connections from the connection vault will not mess up the welding. The only time we mess up the welding is where we do the welding ourselves. Sometimes you might want to check the weight of objects. So we could be doing an extension, or we could be, say we're replacing someone's roof and we've got to put some extra beams into the house, but we can't crane them in. It's got to be a couple of your labourers or your site fitters. You want to double check the weight of assemblies before you go too far. On our little checking tab, if you click the little drop down button, you have an assembly weight information button. So if you click on any object, it will mark what's attached in the workshop, and in your command line it will say the assembly weight is 442.49 kilos. The exact weight is 429.93. So the difference between the weight and the exact weight is the system will take into consideration the weight of the material that is removed for the holes. So the assembly weight information is the weight of the raw material. The exact weight is with the holes removed. This check and all the weight information checks in advanced steel don't take into consideration welds, and they won't take into consideration weight for finishes. So it's just the weight of the steel. It's just the volume it's calculating. So that's one check you can do. The other check is a center of gravity check. So this balcony frame in here is being craned in. So we need to know where the center of gravity of the frame is, because it's obviously just not a perfect rectangle. We've got beams offset here, we've got end plates on, we've got a full channel on this side. So what you need to do is mark your assembly, select the whole assembly, and then on the checking tool we've got center of gravity and total weight calculation. So again, that will give you the total weight. It will give you the center of gravity relative to the world UCS, but what it will also do is it will put a little AutoCAD point in the center of gravity of your assembly. So if I select the marked objects and the point, that point in there is the center of gravity of your assembly. So then what you could do is you could do a distance command from the bottom left corner here to that point there, and that's your center of gravity from that point. So I can't automatically get this to go into fabrication drawings, but by doing that measure tool I could then open the fabrication drawings and position that if you needed the center of gravity. The last check I'm going to show you in today is how to find rogue welds. So when you're putting welds in, you might accidentally weld two assemblies together. So we're just going to have a look at the staircase. So I have a model view set up for the staircase. So a model view is how we can very quickly and easily isolate just particular areas of the model. And it's controlled with these cubes, so you can make them a little bit bigger. But that means I can isolate just the staircase very quickly. I have done a webinar, and the webinar topic was the Project Explorer, so I go through the whole Project Explorer. But model views are very powerful because we can turn them on. We can turn more than one on, so I could have the staircase and grid line 1. So that will give me just both of those areas. If I'm not interested in grid line 1, I can turn it back off. So this staircase, I started with the railing macro, but then I deleted the macro and started modeling manually. So I want to check that I've got these panels as I want to fabricate them. So I do my clear marking, and what I actually used to do is do the clear marking, select the objects, and then turn them off. So right, that's one panel, that's fine. Again, we'll go up the inside of the staircase. Start with a part of the first panel. That looks good. By turning them off, you can see any elements that are left behind. So I would then, we'll choose that one. So that is my little panel. So again, turn that off. So we're just working our way up the staircase. Some people would say this is quite laborious, but as a check, just make sure that we don't get to site and we've got little floating bits of balustrade panel or they're attached to the wrong component. So when I was checking it, if I go through this whole job and the whole staircase is left behind with no balustrade components, then I know it is connected as I would expect it. So as I'm doing that, let's just repeat that. Now when I do that and I turn it off, it turned the bottom panel and the top panel off at the same time. So I've got a problem. Those two panels are connected together somehow. So what I'm going to do, I'm going to isolate those panels. So I'm going to do show only selected objects now. So I'm working on just these two panels. They should not be connected together. So when I click this post, that panel at the bottom should not go red. So we need to investigate and figure out why that has happened. So I'm going to clear the marking. The best way to do this is to be in a 2D wireframe. We've got these two tools in here, which are display connection means and clear marking and display connection means. So what I'm going to do is I'm going to draw a window around just this panel and right click. That will then mark in red every connection element. So the connection elements are bolts and welds that are connecting everything in what I selected. When I select them, everything gets highlighted. Now it's quite hard to see. So another little tool for you is anything that is marked. There is a button here that says search for marked objects, and that will give you arrows to every marked object. So we can see that all the arrows are pointing to everything on that panel. So there is a rogue weld somewhere on this panel that is picking up the objects in this panel. So if I clear the marking, draw a window around this panel and right click. If I now, again it's quite hard to see, but if I then say show me the marked objects, you will see that I've got two arrows going to this side. So for whatever reason, I've manually put these welds in. I've actually, when I was putting those welds in, selected this panel and this panel. So what we need to do is I'm going to go to the Objects tab, and with welds you can remove welds from a connection. So I'm going to delete all of the objects of this panel from these two rogue welds. So I'm going to say this little button in here, remove or delete objects from a connection. It then says what is your connecting element, the bolt or the weld. So it's these two welds. And then what do you want to remove from those two welds? Well, it's actually everything here. Now if I repeat my checking and I select part of that panel, we'll see that only that panel has gone red. So I've sorted my welding out. If I repeat that for the top one, only that top panel has gone red. So that's how you can hunt out rogue welds that are connecting elements. And all this is just stuff that we as detailers are doing manually. So again, it's just trying to make sure that any human error that we put into the model, we find before we get to the fabrication stage or before elements get to site. People who fabricate things, so guys in your workshop will always go on the mantra of measure twice, cut once. Well, I would always go with a mantra, check your model twice, only run your drawings once. That actually is the end of what I'm showing you today. Does anyone have any questions on what I've shown you? This is being recorded, so it will be recorded. It will go on to our Advanced Steel Content Center. This is a repeat webinar, so I did do this webinar 6 months ago, but the recording will update for this webinar. I have done an entire blog on every checking tool, which again links back to this webinar. But I will keep the webinar going for a couple of minutes if anyone does have any questions on what I've covered today. And if not, thank you very much for attending this webinar. I do have one more webinar this afternoon between 3 and 4 o'clock where we're going to be looking at modelling secondary steelwork in advanced steel. So I'm going to show you some tips and tricks just for modelling steelwork. Then I'm going to show you a couple of power pack tools if you have the Graitec Advanced Steel Power Pack. And then I'm also going to show you the stairs and railings BIM designer and what we can do within that. So hopefully I will see you on this afternoon's webinar. I don't see any questions popping up, but I will keep the session running for a minute more. If you don't have any questions, hopefully you found it useful, and thank you for attending.